Hello, today we are going to show how Alu Design in RISC-V CPU is built in Quartus Prime and also show the waveform of each component. First, this is a full adder 1-bit. It has some logic which is calculated using two cascade XOR gate which determine the result by checking if an odd number of inputs are high. Next, it also have a carry out which is use 3 AND gate to detect if any two inputs are simultaneously high, passing those signals through an OR gate to signal an overflow to the next bit. This is the waveform of the full adder. The result is true, according to the truth table. This is 4-bit full adder subtraction, which is it has 4 blocks of 1 bit. We get the block by convert 1-bit full adder circuit into block diagram. It has two input A, B and C in and output sum. In the bottom, we can see that C out is ignored. So this is the waveform of the 4-bit full adder subtractor that we run in the Quartus Prime. Next, this is a 1-bit of 4x1 multiplexer using 2 NOT gates, 4 AND gates and 1 OR gate. This is the waveform of the 1-bit 4x1 multiplexer. The waveform result is true according the Boolean expression and truth table. This is 4-bit of 4x1 multiplexer. We can see that there has a 4 block of multiplexer which is from 1-bit 4x1 multiplexer that have been converted into block diagram. It has 4 block diagram means that it has 4 1-bit 4x1 multiplexer. There has 6 input I0, I1, I2, I3. SO and S1, the output is only sum. This is the waveform of the 4-bit 4x1 multiplexer that we run in Quartus Prime. This is the register. It has 4 of 1-bit D flip-flop. Each bit of the input is inserted to the D input, means that input D0 is connected to first D flip-flop, D1 to the second, D2 to the third, and D3 to the fourth flip-flop. It also have an input reset and clock and output Q out. This is the waveform of the register that we run in the Quartus Prime. Then, this is the full adder subtractor XOR and XNOR Alu. It represents the internal structure of a 4-bit full adder subtractor. Each full adder processes 1 bit of operands, with the carry out of each stage feeding into the carry in of the next higher. Has 4 input A, B, S1, S0. B input bit passed through the XOR gate, which controlled by a S1 input to determine whether the Alu perform addition, subtraction, XOR or XNOR. This is the waveform of Alu that we run in Quartus Prime. This is Alu Design for RISC-V CPU. It contains 3 components. It consists 2 of 4-bit 4x1 multiplexer on the left component, which is the input is A and B respectively. In the middle, it has Alu Design that we already convert into block diagram from the full adder subtractor XOR and XNOR Alu. At the right, it has a register that we also convert into block diagram from 4 of 1-bit D full flip-flop. These 3 components connected in series to make Alu Design become more function. To perform addition, we must insert 00 input to S0 and S1 in Alu. Subtraction is 0, 1, XOR is 1, 0, and XNOR is 1, 1. The function of this Alu can carry out through assembly instruction. This is the result in waveform when we perform addition, which is 0, 0 into S input group. This is the result in waveform when we perform subtraction, which is 0, 1 into S input group. This is the result in waveform when we perform XOR, which is 1, 0 into S input group. This is the result in waveform when we perform XNOR, which is 1, 1 into S input group. That's all from us. Thank you.